Here at Habitat, the last year and a half or 2 years, we've been developing a different type of way of building a house. And so this all started with a conversation with the students at the Caroline High School. And so their shop teacher there, Noah Hughes. And so we have a partnership with the Caroline High School. So the students want to be involved in how to design a house and, you know, the history of like codes, building codes and everything.
Yeah.
So the subject really started there to develop what we have now. And so we started out with a concept that Jason Tickle, our CEO, had in mind, and that's to design a house with a zero-step entry, and we have something right here that we can take a look at as a zero-step entry. And so this is a model that we did at the school to show the students how we're going to design the house to have zero-step entry. And the keynote piece right here, this representing the foundation, and we just simply took floor joists and we just dropped them inside the foundation to eliminate the height so that we could have an ADA, American Disabilities Act, and see it brings the house into profile that's the height of what we know as concrete slab homes.
Yeah.
But indeed it's not. It's built traditionally over a crawl space, and we can talk more about that, how that evolved. But this is a prototype of what we were trying to accomplish to get a zero-step entry home.
I never thought that's how you. That's a great way to show it.
And this is what we built to show them. They were designing the home. They're going to build a house with the intentions of selling the house to a veteran. So in the case of the veteran, it may have handicap needs, but our homes are built for what we refer to as aged in place. And in order to have aged in place, we want to get people in the house with no steps, wheelchair accessible.
Yeah.
But once we're in the house, we'll go in there and show you the flow of the house. So anybody with a walker or cane or even a wheelchair can age in their home and don't have to leave their home because of their disabilities. So as you go in, you can see we've created a zero-step entry, and we have a wheelchair sill right here to even help us with that concept.
Yeah.
And so we move into the house. Now the house was designed where we split the bedrooms, where we have the owner's suite on this side of the house. So we're able to widen the doorways and create space for the owner as he goes into his bedroom, his closet, and the bathroom. And if you notice that the doors are wide enough for access, there's an American Disabilities Act called ADA. So these houses are designed to be ADA adaptable, not necessarily ADA compliant. So in the bathroom, what we need is a space here large enough for a wheelchair, a 5-foot space to allow the wheelchair to spin around. You know, it's a very livable home, regardless if you're handicapped or not.
Right.
And you see even like the utility areas, we made a pocket door here. So again, anyone with a walker, cane, wheelchair is able to live in the home. Open spaces and everything. There's a new conversation in the building industry called building science. And through this conversation with the students, then we have designed and built a house with the sole purpose of figuring out what is the best way to build a house in Caroline County. And the conversation went into understanding that in order to build this house correctly for the environmental impact to this house, that it had to be a regional concept. It had to be, the information had to come and be specific for Caroline County. So we did a climate study to see what would influence the house from the outside. And this is part of the building science, is to take an envelope, the house, a balloon, and see what influences that structure from the outside as well as from the inside. And so through the building science, and because of COVID told us that the modern houses are stopped up too tight and they're unhealthy. So to create a healthy home, what do? What do we look at? And so in the climate study, we realized that Caroline County is one of the more difficult areas to heat and cool a home, because we have extremes of hot, we have cold, but also we have high humidity. And we realized the humidity in Caroline County is very similar to Summersville, South Carolina, because I have family there, so I just did a study in that area. They have relative humidity that's averaged 75 to 78%, where Caroline County is 72 to 76% year round. So we have the humidity that South Carolina has, but we have the extreme of cold and heat that they don't have. They have warmer weather. We tend to trend toward the north with cooler weather for a few months. So as we looked at that, all of a sudden we understood that we had to change some of the dynamics of the house in order to control the influences from the outside of the house. And so in the research, we found out that Brown makes it a piece of equipment called an ERV, Energy Recovery Ventilator, and that ventilator helps us control the dynamics of fresh air coming into the house. And we need fresh air into the house to meet the standards of the Energy Star. But this new unit is controlling the contaminants that come into the house. It filters out pollen, dust, and it helps transfer some of the energy and save some of the energy that comes and goes in the house and the humidity. So as we looked at this ERV, then we had to do certain things to the house structurally to keep moisture out of the house. One of the things in the earlier video you saw with the floor design, we use a product called Zip Wall, and we tape the joints, and it's coated with a green coating that helps keep out air and moisture infiltration into the house. So once we start controlling the environmental impact of the envelope from the outside with thermal pane windows and energy efficient doors, and we have an R42 in the attic. One of the things we looked at was to have a conditioned crawl space. And by having a conditioned crawl space, we keep all the equipment, the air handling, the ductwork within that area. So now, in order to keep out the moisture, we encapsulate the crawl space. So now we're controlling any environmental effects on the crawl space area. We all know that basements are cooler than regular homes. So by shoving the house into the ground further to help us with the zero-step entry, we're now able to utilize some of the temperature changes that's underneath the crawl space. So we encapsulate it, we condition the air, we pump air into the crawl space, and then we provide a return from the crawl space, and we put it directly below the return for the house. And right now, if you feel this, we're getting an 8 degree to about a 20 degree cooler air coming from the crawl space that's being brought into, and that air has already been conditioned. So we bring it back to the return here. We'll take stress off the heating system for the house. So by encapsulating the crawl space and controlling the environmental effects and pushing it in the ground, naturally we're saving energy through this new system.
This is the perfect house.
Well, we have new modifications coming up. But the magic to this is the ERV. And this is the unit that we have for the ERV. And so it's known that fresh air is coming into the unit right here. It's crossing in this box right here that has a filter system. We're bringing that air that's been cleaned, all the moisture has been kind of transferred, the heat has been accepted, and we have filters in there to keep out pollen. We bring that fresh air in, we're taking it and dumping it into the cold air return of the house. And we're doing that about 10 to 15 feet in front of the air handler that has coils to help reduce any moisture that the ERV couldn't translate back outside. And so the fresh air now is conditioned from the outside, controlling what's inside, going into, and it's then circulated out throughout the house. And we have a exhaust in the kitchen that brings the exhaust from the house. If you pump air into the house, you have to pump air out. So we can exchange the air in this house as little as less than a day to take to exchange all the air in the house, up to 3 times a day. We can set the controls to. Now, by doing that and controlling the environment, and then we do all the controls, we have a floor system that doesn't emit any kind of gases or anything like carpets may do. So our houses are now set and poised. We haven't got them EPA certified, but because of COVID, we can actually have this house EPA certified for a healthy home. And it cuts down on the sickness for the family and everything. So if we open this up, we can see some of the magic that happens as the air comes in here, goes through this filter, goes into the house, comes back out from the house, and goes outside. So you see the two fans here, they spin in different directions and different speeds to create what we're looking for to help condition the air. Now the other thing that I find fascinating about this unit, it keeps the barometric pressure of the inside of the house the same as outside of the house. And so if you have a balloon and you keep the pressure on the inside the same as outside, now no air is getting through the nipple, so to speak. So we're not losing any energy. And so now we have fresh air being introduced to the house. It's being controlled by this little box right here. So this thing helps us to control the moisture, the heat, and the barometric pressure. Now, in the house, your comfort level is how much moisture you have in the air and what the temperature is. So this is helping us stay real comfortable within the home, is saving energy. The other thing it helps us to do, so it controls the effects of the environment from outside. Also, we use it to control the environment on the inside. The biggest contaminant on the inside of the house would be the moisture. And you can hear the exhaust fan running because we have a moisture sensor connected to the exhaust fan. And once the moisture in here reached a level of 55%, that's where we have it now. So 55% relative humidity, the sensor comes on, turns the fan on, and just at the impact of the contaminant, at the shower, we're catching the moisture and just blowing it directly out. The strange thing we learned is this is just a standard fan, been used for years and years. But now as we builders are enclosing the house and stopping up the houses, the fans are not working effectively. It's because there's no air being introduced to this space for the fan to suck out. So you can't pull a vacuum. If you suck through a straw and stick your finger at the end of the straw, you don't have any effect. So we have to introduce air so that the moist air can be exhausted outside. In order to do that, we're putting a grill over the doors in the bathroom. The fan comes on, it sucks the air. The ERV senses a barometric pressure change, and so we have to have more air. So it pumps the house up with air. Air flows through here. Now we have an effective way to get the moisture out of the bathroom. And so this whole magic is built around the ERV to keep the house in good shape.
Has that been around, the ERV been around a long time?
ERV has been around, as far as I know, about 30 to 35 years.
Okay.
They're used commercially. I understand from our local board of supervisors who's an engineer for like ships, that's been on ships for many, many years. But it was really no market for it until COVID came. And then COVID says the houses are not healthy. We're just recirculating the same air within the house. You had a couple of people, maybe a pet in there, and then the carpets were emitting gases and everything. So we have so many problems for people that have allergies and asthma and things like that. So we needed healthier homes. So because of COVID, it opened up an opportunity in the market to say, hey, we need to rethink how we're building homes. And so it's been an interesting conversation.
A lot of research too in all of this.
Well, see, it's been a real fun experience for me because we're doing it with the students at the high school. They are presently building one of these houses. We're developing a subdivision in the area. We've donated a lot. Habitat for Humanity has donated a lot to the school system for them to be able to build one of these homes. So for me, at my career now, it's just been a real interesting conversation. It's not one that's I've heard a lot about. And so with ERV, it changes the dynamics of the heating and cooling of the house, which means the new computer programs, there's a manual or a computer program that helps us design the sizes of the air handlers and the ductwork and everything called Manual J. So the old computer program, then it computes the Manual J, then include the ERV, which is bringing in more air that has to be calculated in the formula. So we were lucky to find a local contractor that had the new computer programs that help us realize the difference in the effect it's going to make on these units. So we're pretty confident that we have not only an energy efficient home, but a highly energy efficient home, and it'll be a much healthier home. The cost of an ERV, this unit is costing us right at $850 to $1,000 plus a little ductwork.
That's worth it.
Our homeowners have to install it. So, but for a regular contractor, maybe $2,000, $2,200 addition to the house. But the energy it saves in the long run, and easy to get a return on your investment on this. And then the ERVs, the International Building Code has already started mandating that you have to have an ERV in a residence. And it just hasn't been adopted by local codes. But very shortly, all houses will have to have an ERV as part of their equipment for the house.
Yeah.
So
fascinating.
Yeah,
Thank
it
you.
is.
This
Great
is great.
journey.